All right, let's get started. Today we're going to talk about solving multi-step inequalities. It's going to be very similar to the last section, solving one-step inequalities, and very similar to solving multi-step equations. So let's go right into it. All right, so let's take a look at our first example. So what we want to do is solve 2x minus 9 is less than 15. And again, like we've been doing with the one step, be able to graph this solution. So, first of all, notice you have 2x minus 9. Last lesson, we simply solved things that had only one step. Either we had to add the 9 or divide by the 2. In this case, we have to do both. Okay? So remember this, anytime we have to solve a multi-step equation, you remember PEMDAS, or I guess I use the G at times for grouping symbols. Remember when we do this, majority of the times for most problems, we want to start with the adding and subtracting first, get rid of those things, and work up to parentheses. We're going to go opposite the order of operations. So in this case, we're going to start first by going with the minus 9. We're going to add 9 to get rid of it. That's going to cancel out. We're going to have 2x then is less than 15 plus 9 would be 24. And then lastly, divide by 2, because remember 2x means you're multiplying, so I'm going to do the inverse to divide, and that's going to tell me x is less than 12. Okay, so there's my solution. Again, what I always want to do here is represent this solution on a number line, because we're not looking at just one number as a solution, but multiple. So I'm going to place 12 over here. Let me place some numbers above and below. So 13, 14, 11, 10, and 9. There's my goofy number line again. Then to represent less than 12, I'm going to put an open dot at my boundary of 12, and I am going to include all the values less than, so I'm going to draw an arrow to the left. Okay, so very similar to solving multi-step equations, but again, we're just looking at inequalities. All right, next two examples, I have 12 is less than or equal to, oh Jesus, holy strawberries, we have ourselves a fraction. I can't solve this, but I have 1/4, parentheses, 4x plus 8. Hey, you know what? Just because there's a fraction doesn't mean we can't solve. Of course we can. So we're going to start first where my x is. I need to get rid of everything. Now we have, again, multi-step equations, so I'm going into this assuming that we remember how to solve these things. Notice first I have parentheses with a number on the outside. What the heck do I do here? So remember, what I need to do is distribute this 1/4 through the parentheses to each number. So I'm going to take 1/4 and multiply it by 4x and multiply it by 8. I'm going to distribute, which means to multiply it by 4. Okay, now we got to think 1/4 times 4. Heck, for you guys, I'll write this out, times 4, and I'm going to keep the x, plus 1/4 times 8, and that's going to be greater than or equal to 12. Again, when you're multiplying fractions, you can think, okay, I'm going to place this 4 over 1, 8 over 1, and watch, I'm going to simplify here. The thing you guys forget to do, simplify that 4 down to a 1, and this to a 1, that's going to give me 1x. Simplify this down to a 1, and this to a 2, that's going to give me plus 2. And that's going to be then less than or equal to 12. Okay, now I have a more simpler, I guess, two-step equation to solve. I have here plus 2, then I have the times 1. So I'm going to start with this plus 2. I'm going to subtract it from each side. I'm going to write this over to the side here. So 12 minus 2 is going to be 10. That's going to be less than or equal to. And careful here, you notice how I have 1x. Okay, 1x is simply just x. So I don't need to divide by 1. I don't need to waste my time with that extra step. What I have here is 10 is less than or equal to x. Again, I like to write this in the correct order from left to right. So I have x, the opening is pointing towards x, so I'm going to go greater than or equal to 10. Okay, it might help some of you to write it that way. So I'm again, draw this in the number line. I have 10, 11, 12, 9, 8, and 7. Choose some numbers above and below. I'm going to put my boundary at 10. It's going to be a closed dot this time because it's greater than or equal to. And then representing all the values greater than, I'm going to put an arrow to the right. Okay, next one. I have 5x plus 6 is greater than or equal to 2x minus 5 plus 3x. What do I got going on here? Well, notice I treat this as like our equal sign. I got variables on both sides of the equation. So now I have to get the variables to one side. Okay, and hopefully this is bringing back some memories of solving equations. Okay, now, first of all, what I'm going to do before that is I'm going to try and simplify each side as much as possible. So here, 5x plus 6, I can't simplify. Now, can I simplify anything on the right side? Yes, I can take and combine like terms. So I can combine 2x and 3x. So the left side is going to stay the same. 5x plus 6 is greater than or equal to 5x minus 5. Okay? Then what I'm going to do here is I have to move really the x's to one side. So I'm going to start with, I'll just go from this one. This 5x, I'm going to bring it across. So I'm going to subtract 5x since it's positive. Subtract 5x. Now, careful here. What is 5x minus 5x? Well, just like over here, 5x minus 5x cancels out. So this cancels out as well. And here's what I'm left with. 6 is greater than or equal to negative 5. Now, I want you to think about this. We have seen this before, and we haven't seen this in a while. But what does it mean when the variable cancels out, and I'm left with 6 is greater than or equal to negative 5? This right here is a statement, okay? When the x cancels out, remember there were two options. The first option was that it meant no solution. The second option was that it was all real numbers, meaning any number would satisfy this inequality, or in the case of an equation. How do we know the difference between whether it's no solution or all real numbers? Well, we know the difference by the statement that's left over. We have to ask ourselves, is 6 greater than or equal to negative 5? Well, we know that 6 is definitely greater than 5. So this checks out. This is a true statement. If it's a true statement, remember it's all real numbers. Now the question is, how do I represent all real numbers on a number line? That's kind of interesting. I'm not just representing, my boundary and above or below it, but I'm representing every single number. Well, here we go. On my number line, let me just label 0, 1, and 2, and then go negative 1, negative 2, negative 3. So I'm going to represent 0, some positives, and some negatives. What this means is that every number works. So how do you think I should draw my arrow to show every number? The way I'm going to do this is I'm going to put a straight line with no boundary with arrowheads on both sides. Because what this is representing is that any solution would work. So there's no boundary, but instead it's just a line representing every number. All right, next one. So anything special here? We have, again, parentheses, variables on both sides. Let's go ahead and start first by distributing. So I'm going to take 2, distribute it to 3x minus 4. So I'm going to have 6x minus 8. Again, careful to distribute that to both. That's going to be greater than 6x plus 4. Again, I'm going to solve. I'm going to try and get the variables to one side. So here I'm going to subtract 6x from the right, bring it to the left. And again, what do we notice? Oh my God, the 6x's cancel out. And I am left with negative 8 is greater than 4. Okay, so go back to the last one. What did it mean if negative 8 was greater than 4? Again, this is a statement. The variable cancels out. So we have to look, is this statement true or not? Is negative 8 greater than 4? You may say, yeah, 8 is greater than 4, but this is a negative 8, and this is not greater than 4. So what does this mean? No solution. And then lastly, can I represent no solution on a number line? No. So my number line is going to be blank. This one has no solution. So these last two examples, look to see if that final statement is true or not. If it is true, it's all real numbers. If it's not true, then it's no solution. Oh, here we go. Dreaded word problem. Ha! Well, everybody loves a little kitten, so hopefully this one makes you smile a little bit, hey? So we have Timmy Cat is on the prowl. The kitten crusader has caught 5 bad guys already today and hopes to be able to catch 2.5 criminals every hour. So we got our little Timmy Cat who's catching bad guy criminal kitty cats, right? So imagine this right here is Timmy Cat, the man. So I want to know, what are the possible amounts of hours that Timmy Cat needs to be on the prowl to catch at least 30 bad guys? So I want to know the number of hours. We're going to label that as X. Here's what we know. We know that Timmy Cat has already caught 5 bad guys. So we're going to start off with 5. We know that he has 5. And it says he's going to catch 2.5 criminals every hour. So how are we going to label that? He's going to start off with 5, and every hour he's going to catch 2.5. So I'm going to write that as plus 2.5x. And what I hope, or what Timmy Cat hopes, is he hopes to catch at least 30 bad guys. So think about this, at least 30 bad guys. Does he want to catch less than 30? No. Does he want to catch 30? Well, that would be good. And does he want to catch more than 30? Of course he does. So he wants to catch more than or equal to 30. Otherwise, I guess, greater than or equal to 30. So the amount that he wants to catch must be equal to or greater than. Okay, so what we have here now, we just got to solve. So I'm going to subtract 5 from both sides. That's going to give me 2.5x. Again, this cancel, sorry, is going to be greater than or equal to 30 minus 5 is 25. Then lastly, I'm going to divide by 2.5 on both sides. And that's going to give me x is greater than or equal to 10. Okay, so that means Timmy Cat has to work at least 10 hours. Okay, he's got to put in a full day's work in order to catch those criminals, and I certainly hope that Timmy Cat does, you know. All right, next thing I want you to go ahead and try these. So I want you to pause the video right here, give these two a whirl. The first one, oh my gosh, you have a fraction. Everybody, time to freak out and quit, right? I joke, you don't quit, right? Just because there's a fraction, you'll be fine. Take a look at the other problems. I'll just give you a hint, hint, nudge, nudge. Things are going to work out just oh so nice in this problem. Okay, and then number 2 as well. Again, we're going to be solving these multi-step inequalities. So give this video a pause, and here we go. All right, let's take a look at the first one now. Here we go. Our solution, first thing you had to do is distribute 1/8 to 7x and minus 8. Okay, so